All right, this is the pre-calc first part of Chapter 4 review for our test that we're going to have. Number 1, it says find the angle in degrees that describes the compass bearing. Don't even worry about that one. We really didn't talk about compasses, so I'm not going to even bother with that. And then number 2, it says determine the given function, whether the given function is positive or negative. So positive, negative in quadrant 2. So we have our axis, or our coordinate plane. This is 1, 2, 3, and 4. So we now have the cosine in quadrant 2. So we have some angle that comes over here, lands in quadrant 2. I don't even know where it lands. It doesn't even matter. In quadrant 2, x's are negative and y's are positive. And for cosine of the angle, and t, t could be theta, it could be any angle, just a variable for that degree. Cosine is equal to x, and x is negative, so my answer should be negative. Number 3, it says evaluate the trig function of the given quadrantal angle. So it's a quadrantal angle, which means it's going to either land on the x-axis or the y-axis somewhere. And it says if the value is undefined, write undefined. For this guy, it's going to come around, and obviously it's more than 360 degrees. Basically, you just keep subtracting 360 until you get to a value that's on the coordinate plane. And it ends up being equivalent to the cosine of 180 degrees. And at that point, it's equal to -1. Number 4, convert from degrees to radians and use the value of pi, it says found on the calculator. Normally we leave it in terms of pi. If it does give you the instructions to do that, go ahead and give me to the 4 decimal places. If you leave it in terms of pi, I'll count it as well. But if we're going to go from degrees to radians, you just multiply by pi over 180. And if I reduce the 30 and the 180, I'm going to get pi over 6. You could put that in your calculator, take pi divided by 6, and then round that to 4 decimal places if you wanted to. If we were going to go from radians to degrees, we're going to multiply by 180 over pi, just do the opposite. Number 5, it says solve the right triangle for all missing sides and the angles to the nearest tenth. So you've got 6 sides, you've got 6 angles, and you want to find all of those. So what I would do before I get started is I would make a list of my angles. Sorry about that. I would make a list of my angles, the measure of angle A, measure of angle B, measure of angle C, and then we have A, B, and C. And then I'm going to write down any information that I have that's given already. I know that C is 17, so I'm going to put that in there. I know that B is 32.4, so I'm going to write that one down. Oh, wrong C. C is 17, there we go. B is 32.4. And angle C is 90 degrees. So we know that there are 180 degrees in a triangle. If to find angle A, that's equal to 180 minus the sum of the other 2 angles, which would be 90 plus 32.4. And so the measure of angle A is 180 minus 122.4. And so that's going to equal 57.6 degrees. So that's the measure of angle A. So we've got that guy. Now I want to find A and B. Since I don't have two sides, I can't use the Pythagorean theorem yet. So what I need to do is use one of my trig ratios. I can use sine or cosine, either one, because they both have the hypotenuse in them, and I only have the hypotenuse. So I'm going to use sine here of the angle that they gave us. Just in case you make a mistake with angle A, if you use the one that's given, you won't miss this part. So I have sine of 32.4 degrees is equal to the opposite side. The side opposite is B over 17, which is the hypotenuse. And you multiply by 17 on both sides, so that B is equal to 17 times the sine of 32.4, which is approximately 9.1. And we're just going to go with that. Then you can either use another trig function to find A, or you can use the Pythagorean theorem. My guess is most of you are going to want to use the Pythagorean theorem. So that's A squared plus B squared equals C squared. C is always the hypotenuse. Number 6, it says evaluate. Number 6, evaluate without using a calculator. So what we want to find is the secant of the angle, and they've given us 2 hints here about what the function is, or the ratio is. We know that the sine is -3/10, and we know that tangent is greater than 0, which means that the tangent value has to be positive. So I'm going to start with, I have secant of beta and secant is the reciprocal of cosine, so I'm going to have r over x. And then I know that sine beta, which is y over r, is -3/10. R is the radius, so it's always going to be positive, as it's a positive length, no matter where you are on the coordinate plane. So -3, or 3, has to be the negative number. So that I've got y equals -3, r equals 10, and I need to know what x is. So I'm going to take my y and my r, and I'm going to put it in the equation. R equals the square root of x squared plus y squared. I put those values in. So I know that r is 10, so I'm going to put 10 in. And I want to find x, so I'm going to say x squared plus y squared is -3. Just put it in that equation. So 10 equals the square root of x squared plus 9. And I'm going to square both sides. And that gives me 100 equals x squared plus 9. We're going to subtract 9, so that's going to give me 91 equals x squared. And when I take the square root of both sides, what I actually get is x equals plus or minus the square root of 91. And it's plus or minus right now. I don't know if x is positive or negative. I'm going to use my second hint up here about tangent, this guy, to figure out whether x is positive or negative. I know that tangent of theta is y over x, and I know that the answer has to be positive. That's what it tells me, because tangent is greater than 0. The y that we have is -3. So we need to figure out what the x has to be, and we don't even care what the number is. Is it positive or negative? If it's positive, a negative over a positive is negative. So that's not going to work. If it's negative, then a negative over a negative is a positive. So we know that x has to be a negative number. So x is actually going to end up being negative square root of 91. So we can put that up in there for x. We're not done. That's just what x and y and r are. We need to find secant, so we're going to fill that in. We're doing this guy right here. R was 10, and x was negative square root of 91. And that'll simplify to negative 10 square root of 91 over 91. It's that guy right there. Number 7, find the value of the unique real number theta between 0 and 2 pi. 0 and 2 pi, that just means all the way around the circle, and they use those so they want us to give our answer in radians. So we have tangent of theta is 1, and we know that sine is less than 0. So sine is some negative number. Okay? Which means that since sine of theta equals y, then y, the y coordinate where the angle is has to be negative. Tangent is y over x. So if y is negative, and x is negative, and we get 1, x has to be negative in order to get 1. So we want in the quadrant where our x and y is negative, so that's going to be in the third quadrant. So here's what it's going to look like. We're going to have an x coordinate of, we'll say this is negative 1 and negative 1 here to give me positive 1. We'll have an x coordinate of negative 1. We'll have a y coordinate of negative 1. And so there's a point. And if I do the Pythagorean theorem, this is square root of 2. Well, what angle has those sides? That's a 45-degree angle. So we had to go 180 degrees plus 45 degrees in order to get our result, which is 225 degrees. That's what theta equals. Number 8, determine whether the given function is positive or negative for values of t in the specified quadrant. So it's like the first page where we've got our coordinate plane. This time we are coming around here and we're going to end up in the fourth quadrant, so we're over here. In the fourth quadrant, the x is positive and the y is negative. And it wants to know what tangent is going to be. Well, remember tangent of, whoops, not tanny, tangent of theta or t or whatever you have is y over x. And y here is negative, and x is positive, so negative over a positive is negative. So our answer is, it's a negative number. Number 9, it says use a calculator to find the function value to 4 decimal places. So what I would do, and you can do this if you've got your calculator with degrees, minutes, and seconds. But if you don't, I would change this to all degrees and then find the sine of it. And so we change it all degrees by taking the 31 degrees plus, and then we're going to change 59 to degrees by taking 59 minutes over 60 minutes, which is the same as a degree, plus the 24 seconds over, they're actually 3,600 seconds in a degree because it's 60 times 60. and we're going to add that all together. And that gives me about 31.99 degrees. So I'm going to take the sine of 31.99 degrees, and that's 0.5298. Just use your calculator for that. All right, we're going to look at a different way, maybe an easier way to solve a problem like number 10 here that says find the value of the unique real number between 0 and 2 pi. So again, we're going to be in radians. And we know that tangent is -1. Tangent of theta is y over x again. And in order to get a negative, we either have to have a negative over a positive or a positive over a negative. So our x and y coordinate has to be, one has to be positive and one has to be negative, and it has to be the same number because that's how you get a 1. Okay? And I'm going to go look at the unit circle for this. We also know that the sine of theta is greater than 0. So the sine, which is in this case y, it says is positive. So that means we're looking in the quadrant where y is positive, x is negative, and they're the same number. So I'm going to go to my unit circle, and my y is positive, my x is negative, and it's the same number. Well, that gives me a 45-degree angle, and so theta has to be 135 degrees in standard position. Number 11, it looks like a weird one, but it's really just about getting the picture right. It says find the distance in kilometers between the cities whose latitudes are given. Assume that the cities are on a north-south line and that the radius of the Earth is 6,400 kilometers. So obviously Earth is a circle. Okay, and here's our Earth. Okay, well, it's a sphere, but we're going to think about it as a circle right now. With the radius as 6,400 kilometers. And we have city A that is 73 degrees north. So think about that 73 degrees, what that would look like, which is about right here. And we'll call that city A. Okay, and then we have city B that's 18 degrees, both of which have a radius of 6,400 kilometers. We want the distance between them. So this is an arc right here. This is an arc length. So we need to find this angle, and we just do that by taking the 73 degrees minus the 18 degrees, which is 55. And we want to find this arc. This is S. When we do arc length with degrees, we take pi times r times theta over 180. R is the radius. So the arc length, or the distance between these two cities on the Earth, is pi times their radius, which is 6,400, times theta, which is 55, over 6,000, over 180. I'm just going to input that all in my calculator, and I get 6,144 kilometers. And that's approximately. Number 12, determine the sign, whether it's going to be positive or negative, of the value without using a calculator. All you're going to do, think about your coordinate plane, and you're going to draw in your 183 degrees. So it's just past the 180 degree mark. In this quadrant, x and y are both negative. Cosine is the x coordinate, and it's negative, so our answer is negative. Number 13, to convert from degrees to radians. We did this before. We're going to take and multiply by pi over 180 to get that result, which if you use your calculator, you're going to get 1.020. For number 14, you can add what's in these parentheses if you want to. You can put it directly in your calculator if you have. Make sure it's in radians. That's also acceptable. One of the cool things about this is it's broken up. So we've got this 270 pi. If you divide that by 2 pi, that's going to tell you how many full circles it makes. Well, 270 is completely divisible. 270 is completely divisible by 2, which is 135. So it's going to make a bunch of revolutions around the circle, 135 times. It's going to end back up at 360. And then it's going to go, so it's right back at the beginning. So that almost doesn't even matter. This pi over 3 is what's going to matter. So we just really want the sign of pi over 3, which is 60 if we're looking on our unit circle. That's that 60-degree angle. And 14 is going to simplify then to square root of 3 over 2. All right, number 15. Find the trigonometric function value of the angle shown. So I want the sine of theta. So this angle right here, here's our coordinates that go with it. We know that sine of theta is equal to y, so that's all it's asking. Excuse me. You know what? I told a story. Because this is not a unit circle. That's only true on the unit circle. Let me go back. Because you'll notice that we have a much bigger radius than that. So what we're going to do is we're going to take our triangle that we see right here, and I'm going to make a bigger version of it. And those coordinates, the x-coordinate is this guy. So that's going to be negative 3 square root of 2. My y-coordinate is negative 4. And I want the sine of theta. Well, sine of theta is y over r. So we need to use the Pythagorean theorem to get the radius. Okay. So r is equal to the square root of the x squared plus the y squared and so if I square negative 3, that's 9, and if I square the square root of 2, that's 2, and 9 times 2 is 18, and then negative 4 squared is 16, so that's the square root of 34, which that's as simplified as it's going to get. So that's my r. So my y was negative 4, and my r was the square root of 34. Number 16, solve cosine of theta is equal to square root of 3 over 2 for theta. Where theta is between 0 and 90 degrees. So we're looking for degrees. Cosine of theta is your x-coordinate, and it says our x-coordinate is the square root of 3 over 2. And between 0 and 90 degrees means we're going to be in the first quadrant. So we want to look at our unit circle. And I've got my 30, and there's my 60. And then my points over here are square root of, take that back. My points here, so that's 1/2, and square root of 3 over 2. for the 60, and the 30 is square root of 3 over 2 and 1/2, and I want the x-coordinate. Which one has an x-coordinate of square root of 3 over 2 is all it's asking. Which is this guy, which makes theta have to be 30 degrees. Number 17, I know there's a lot of big numbers there, but you can just put that in your calculator because this is in radians and find out what the value of that is. I think 17 ends up being just 1. 18, use a calculator to evaluate the function and round your answer to 4 decimals. Now, you got to be careful because this is actually radians because there's no degree sign on this. So your calculator needs to be in radians when you do this. So that when I find the cosine in radians, okay, it's 0.9818. 19, convert the angle to degrees, minutes, seconds. Again, you can do that with your calculator, but I can show you the long way here real quick. You're going to start with 171 degrees, and you're going to leave that part. You're good there. That's already in degrees. We want to change this guy to minutes and seconds. So we have our 0.89, and we're going to multiply that by, because that's in degrees, there's 60 minutes in 1 degree. So we're going to multiply by 60, and you get 53.4. minutes. We're going to keep the 53 part, and we're going to take the 0.4, and we're going to change that to seconds. So we take the 0.4 minutes times the seconds. And that's going to be 24 minutes. And I get 171 minutes, degrees, 53 minutes, and 24 seconds. Okay, last one. We're going to solve for sine of 1/2 in the first quadrant again. Remember, sine of theta in the unit circle is what our y-coordinate is. And so we're looking for a y-coordinate in the first quadrant of 1/2. And that is going to be, if you look at your unit circle, that's going to be where theta is 30 degrees.